Yeah, good morning, students. So the today session will move on to the how to split the concave polygon. So here, in order to split the concave polygon, there are one method, rotational method is used. The algorithm is as follows. First, proceed counterclockwise around the edges of the polygon so that each vertex vk is at the origin, and rotate the polygon in clockwise direction about the origin so that vk plus 1 is on the axis, and if vk plus 2 is below the axis, then polygon is said to be an concave, and then in such situation we need to split the polygon along the x-axis. Repeat it for the new polygons obtained and until all vertices are tested here. And this is an example. You can see that let us v1, v2, v3, v4 is at the below of the axis here. This is what the original diagram. Suppose if I keep the v1 at the origin, so v2 will become actually on the x-axis, v3 will become inside, and v4 will be on the x-axis. So that here in this case the no splitting has to be done here. Then if I keep the v2 is at the origin, v3 will be on the x-axis and v4 will come on the below the x-axis. In such situation we need to split this polygon here. After splitting, you can see that v1, v2, v3, v5, v6 will come under one polygon, and v4, v3, v3b will comes under the another polygon here. Now next is the next topic is how to split a convex polygon into set of triangles. Here once the vertex width of convex polygon is obtained, transform it into a set of the triangles. First, define any sequence of 3 consecutive vertices to be a new polygon. The middle triangle vertex is then deleted from the original vertex list. The same procedure is applied to this modified vertex list to strip off another triangle. We continue forming a triangles in this manner until the original polygon is reduced to just 3 vertices, which defines the last triangle in the set. Next, the topic is how to set or how to test inside outside of a polygon here, or it can also be called as an interior and exterior part of the polygon. And this there are actually the two methods are used to test the inside and outside. One is odd parity rule and another one is the winding number rule. So here in case of an odd parity rule, draw a line from any position to a distant point outside the coordinate extent of the closed polyline. Then we have to count the number of line segment at crossing along the line here. If the number of line segment crossed by the line is odd, then P is interior, otherwise it is an exterior here. So this is an example. You can see that exterior here, number of line segment it is passing is 2, that is even, that is an exterior. And with respect to this interior, the number of line segment is passing only 1, then it is an odd here. Then second method is winding numbers rule here. This counts the number of limits that the boundary of an object winds around a particular point in the counterclockwise direction. Here we need to initialize the winding number to a 0 and again imaging a line drawn from any position to a distant. The line we choose must not pass through any endpoint coordinate. As we move along the line from position P to the distant point, we count the number of object line segment that cross the reference line in each direction. Then we need to add 1 to the winding number if the line segment crosses the line in the direction from right to left. It is crossing from left to right, we need to decrease from 1 here. So this is an example. You can see that from the C to D it is moving from left to right, and from A to D it is moving from right to left. So that here this is here it is a non-zero. Then P is considered to be an interior, otherwise P is taken as an exterior point here. Next is this is the polygon table. The polygon table says that how the information of any polygon will be and stored here. So the information is to be stored in the geometric properties. There will be the 3 table: vertex table, edge table, and surface facet table here. Surface facet table which contains all the edges which is facing to the which surface here. There will be the 2 surface, that is S1 and S2. Next is edge table which contains all the information of the edge and which vertices it includes the edge here. Then vertex table which specifies the vertex values here. In this case there will be a pointer from the surface facet table. It is always pointing back to the edge table, and from the edge table again it is always pointing back to the vertex table. Then next is the plane equation. Then plane equation can be divided by ax plus by plus cz plus d is equal to 0. When you divide d on here, you will be getting a by dx plus b by dy k 1 all. So the generally according to that Cramer's rule, the A value will be 1 1 1 y1 z1 and B is the x2 y2, C is x1 y1 1 and D is minus x1 y1. By expanding the determinants, we can write the calculation for the plane coefficient in the form of A is equal to y1 of z2 z3 plus y2 z3 like this here. So the next is how to specify the front and back polygon tables. So here the side of the polygon that faces into the object interior is called the back face, and it is visible to the outside is called actually the front face here. So the for any point x, y, z not on a plane with the parameters a, b, c, d, we have ax plus by plus cz plus d is equal to 0. Then when do we say that it is behind the plane or front of the plane? Ax plus by plus cz plus d less than 0. Then if ax plus by plus z is less than greater than 0, then it is an front of the plane here. So this is a normal vector. Okay, so this is what the normal vector. So thank you students.